Today, we want to take our trig functions beyond acute angles. Right now, we work with our trig functions and they only give us, they only apply to angles that are in right triangles. So strictly bigger than 0 and strictly less than 90. It's weird when we have an angle of 0 in a triangle because then we got two other right angles and we don't really have a triangle. There's all over on one end and the sides are infinitely long. It's ridiculous. But we still need to apply our trig functions to any angle and then use that to move on to apply trig functions to any number. To do that, we need some machinery. We need to all agree on how we're going to talk about this. And so what we're going to do is we're going to place angles on Cartesian coordinates or rectangular coordinates. So now we're going to put angles on rectangular coordinates. So rectangular coordinates or Cartesian coordinates are the XY plane that we all know and love. Just as a quick reminder, we use X and Y coordinates to label every point on a two-dimensional plane. It's just two number lines that are perpendicular that cross at the 0 of each number line. So if I want the point 2, 3, I go out 2 on the X and up 3 on the Y and look for that intersection. 2, 3. We list our horizontal coordinate first and our vertical coordinate second. We need two coordinates to label one point on this plane. We need two coordinates just like with an address. If I said the address of this school is 3300, that doesn't make any sense. That's only half of a coordinate that this school is located on the two-dimensional surface of the Earth. If I said the address is College Drive, that's also not enough. That's only the Y coordinate. I need an X coordinate and a Y coordinate so I can say 3300 College Drive. That's that first coordinate and the second coordinate. Because we don't have more address systems all over the world, we would also have to be more specific. It's 3300 College Drive, and we would also have to say which local set of coordinates we're using, and we could just use the zip code for that. All the extra stuff that you write on your address, like the city and the state, we don't need to do that anymore. We can just use the zip code. You know what I mean? Which is great, because I remember in school learning how to write an address, and I had to learn all kinds of different abbreviations for all the different states. Instead of having the two-letter abbreviations, they all had their own abbreviations, some were longer than others. Like for California, you would write Calif and then period. I'm like, oh, dude, you're halfway there. Just write the whole thing. But now, Ka. So we just got these two number lines, perpendicular, crossing at the 0 of each number line. There's a positive side and a negative side. So if I have the point -2, I'll do -2, -1. We just go to -2 on the X and -1 on the Y. We're familiar, we use this in addresses as well. Because we would say not like just, we wouldn't say -3300 College Drive. We'd do something like 3300 West College Drive, as opposed to 3300 East College Drive, because no one wants their address to have negative numbers in it. Because as much as we like order, we don't like that much order. Any questions? So every point on the plane needs two coordinates, a horizontal coordinate and a vertical coordinate. We will usually label the horizontal axis with X and the vertical axis with Y. So that'll allow us to say things like X coordinate and Y coordinate. Just for further naming of the parts, X is the horizontal axis. And Y is the vertical axis. For some local notation, this is notation that I use. I put the arrows in the positive direction. So when I put the arrow pointing toward the X, I'm just saying to the right is where you find positive X's, and that makes negatives on the other side. And I put the arrow pointing up to indicate that up is where you'll find positive values of Y, and so down is where you'll find negative values of Y. Sometimes you'll see these drawn with arrows on both ends, indicating they go on forever in both directions. Question? Let's talk about putting an angle in standard position. So an angle theta in standard position has its initial side on the positive x-axis. An angle is in standard position when its initial side is on the positive x-axis and counterclockwise is positive angle measured. So if I want to draw 45 degrees in standard position, I put my initial side on the positive x-axis. And the positive direction is counterclockwise. So there's a positive 45-degree angle. That means our initial side is on the positive x-axis. Counterclockwise, from your perspective, counterclockwise is the positive direction. Clockwise rotation is negative. So if we measure an angle, if we want to draw an angle that's negative, we go clockwise. Our initial side is on the positive x-axis. Negative 45 degrees means we rotate through negative 45 degrees clockwise to get to our terminal side. So here's theta and P in standard position. Yeah. Correct. So positive, if we go counterclockwise, that's positive angles. Counterclockwise is negative angles. Clockwise is negative. Counterclockwise is positive. Did I say that backwards? Oh, okay. Counterclockwise. Okay. Naming of parts. We ought to make sure we're all gonna talk about the same parts. So like not like all this thingy and that thingy and so it is strange to think positive is counterclockwise. Here's one of the reasons why. When we have these two axes, we divide the plane up into 4 quadrants. We're going to divide the plane up into 4 quadrants. And we really want this counterclockwise stuff to go. So in the upper right, that's our first quadrant. And we'll abbreviate that Q1. The reason that we want this one to be our first quadrant is that's where everything is positive. That's where X and Y are both positive. Then we just had to pick a direction and we decided to go this way, like I was there at the meeting. I wasn't there. I skipped that meeting. So we go over here. This is quadrant 2. Or the second quadrant. Here's quadrant 3. The third quadrant. And here's quadrant 4. The fourth quadrant. So you can either say quadrant 4 or the fourth quadrant. Sometimes these are listed with Roman numerals. I don't like that because Roman numerals are bad and they should feel bad. So I just do Q1, Q2, Q3, and Q4. Questions? If I'm using capital Q and it's followed by a number between 1 and 4, I am talking about that quadrant. Okay. Naming of parts. This is the part where you opened up the box from IKEA and it says that little parts list. So you've got 6 of these things, 8 of these things, and you just want to separate out to make sure you have all the parts. Everybody does that, right? You don't just like start grabbing stuff. You make sure that all the parts are there. And then put them in little piles on that piece of paper so you know where they're all, or just randomly throw stuff together. Yeah. If you don't organize the parts, you need to find someone else to build your IKEA furniture. Not because it's going to fall apart on you, but because you're depriving someone of the fun part of the process. It's like, oh, this is the awful part of the project. You know somebody, for whom that is the fun part of the process and you are depriving them of it. This is why my friends were like, hey, Leach, I got a build dresser. And I'm like, oh, tell me more. We got one from IKEA, and I'm like, oh, then the next thing I hear is like, oh, are you there? No, because I'm knocking on your door. This is awesome. I get to build some furniture. And it's gonna be as simple as from IKEA. Then I start labeling the parts, and he's like, well, what are you doing? It's gonna take forever. I'm like, oh yeah, that's right. Get out, go get us some food. I'm gonna label these parts. All right. How's everybody okay? Quadrants, standard position, positive x-axis is where we start. That's where 0 is going to be. So here on the positive x-axis, that's where theta equals 0 is going to be. What angle measure are we at the positive y-axis? What angle measure are we at up here? 90. And then if we go all the way over to this other side, what angle measure are we at? And if we keep going down here on the bottom, how much? 270. Each quadrant is 90 degrees large. Oh, hang on a second. Now we're back at the beginning. What's another word for another label that we could put on the 0 degrees? 360. Oh, wait, but what if we just keep going? What's 360 plus 90? 450. So 360 plus another 90, this would be at 450. And then another one that's just going to be 520, 540. And then this one's going to be, well, we just keep going around. It's going to be 720. And we're getting into Tony Hawk territory. I think, where's 900? Isn't 900 like over here? It's like around twice and a half. That's a lot. So here's one of the issues that we have. We can label the angles from 0 to 360, but if we just keep going, we're going to be in the same places. We're going to have all the same places. 910 quadrants. So it'd be like all 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's a lot. So one of our complicating things is that each angle, when we measure it in this way, when we're measuring rotation, has a bunch of different restrictions. But they're all going to be 360 degrees apart. So once we learn what's going on between 0 and 360, then learning on beyond 360 or before 0, no problem. We already understand a full circle all the way around. That makes sense? It's just like when we were learning our angles, our trig functions and our angles for that first quadrant. We want to know everything from 0 to 90 really well, so that we can take 0 to 90 and copy it into the other 4 quadrants. That'll give us 0 to 360. Once we know that really well, then we're kind of done. Then it's just adding or subtracting 360. And when we introduce radians, it's adding and subtracting 2 pi. So all we need is patterns. I'm sorry about that. All right. Don't use the wrong pens on your Rocketbook. And if you're using the wrong pens on your Rocketbook, figure it out before you go and ruin another page. Ask me how I know. Yes. Also, if you leave it in your hot car, then all the ink might disappear, and you can make it come back by freezing it. So, I don't know. I think it'd be fine. Just let it thaw and you can clean it. All right, so we want to move beyond acute angles. The thing that we're going to do, you can see it down here. It's like coming up. It's like, oh, I'm on my way. we're going to use the unit circle to do this. But to do that, to use the unit circle, we have to take our iconic triangles that we understand so well, and we're going to have to shrink them down so that the hypotenuse gets scaled down to 1. So the first thing I want you to do is scale the hypotenuse down to 1. The next thing that we want to do is we want to draw these triangles with our 30, 60, and 90, 30, 60, 45, and 60 degree angles in our unit circle where the 30, 45, and 60 are in standard positions. So what we're going to do is scale the hypotenuse down to 1 so that we can take this down to our unit circle. Oops. A unit circle is a circle with a radius of 1. That's the unit parts of the unit circle. The center is going to be at the origin for our unit circle. So we know where a bunch of these points are already. So this point here, on the positive x-axis, we have an x of 1 and a y of 0. So the coordinates here are 1, 0. Up here at the top, we have coordinates of 0, 1. Down here, or back here, we have coordinates -1, 0. And then down here on the bottom, we have coordinates 0, -1. And then we're back up to where we start. Here's what we're going to want to do. I'm going to do 45 for you. We're going to take a few minutes and just draw this out. So what I want to do is place 30, 45, and 60 on the unit circle in approximately the right place. So I know 45 is going to come out at a 45 degree angle. So I can just go, I have a grid here. So it's these points I'm going to try to hit. So here's a 45 degree angle. What I want you to do, this is on a unit circle, I want you to figure out what the coordinates are of this point at 45 degrees. I want you to figure out where 30 should go. So I want you to down, oops, 30 is blue, I think. So I want you to draw a 30 degree angle. I want you to figure out where the 30 should go. And I want a pretty good approximation. It'd be nice if you had a very consistent circle where you could easily find the 1/2 the radius. And that would be useful to find. But I want you to draw a 30. And then I want you to draw a 60 degree angle in standard position on your unit circle. So start from the positive x-axis, 45 degrees. Once you do that, I want you to figure out the coordinates of that point. Any questions? To do this, you're going to want to scale the hypotenuse down to 1. So we're going to want, here are our iconic triangles. Hypotenuse is the square root of 2. I want to fit it into the unit circle. Square root of 2 is too much. That's 1.4. It sticks way out here. I didn't draw a circle big enough. So I just want you to find a similar triangle where the hypotenuse is scaled down to 1, figure out what these two sides are, and then you could use those to figure out these coordinates. I want you to do that for 30, 60, and 90. Any questions on what we want to do? It doesn't have to be perfect. You don't have to have your fancy circle drawing tool like mine, because I have this cool circle drawing tool. Isn't this cool? I have my own personal chopper eye. Yeah, it's set up that same way. It has the smallest I can draw, but it's a little expensive. No, nope. I just got a cool drawing tool. The cool thing is that when you close it all the way, you can see it has the name of the thing on the back. Iris by Maker's Cabinet. So, not a sponsored video. All right. So that's what I want you to do. I want you to put 30, 45, and 60 in standard position and figure out what those coordinates are. Where do these land on the unit circle? We're going to do this by taking our iconic triangles and scaling the hypotenuse down to a length of 1 using similar triangles. All right, let's put 15 minutes on the clock. And then try to draw 30, 45, and 60 just in this first quadrant. Then we'll expand. I'm going to pause the recording. So come back for part 2.